Good afternoon, and welcome to the second day of F8, the future of multi-dimensional video capture. You know, we all start our lives and have aspirations of what we want to do when we grow up. And I was recently reminded of this when I was rummaging through a box of memorabilia my mom had handed me recently. And it had Brian's newspaper pictures on it. And at first, you probably all have a collection like this, and you might think that it has pictures of yourself. But it doesn't, in my case. It has pictures that I took, because my aspiration was to be a photojournalist. I wanted to travel the world, telling stories and connecting people with my camera. Back then, I was interested and had the ability to create in a medium that was created for me. Yes, it was that long ago. I was in high school, and I did, in fact, get my first paycheck. My mom saved that as well. And it's telling that my mom saved it because it was important to me. I couldn't find the pictures of me in high school because I was busy taking them. But fast forward some nearly 40 years later, embarrassingly, and instead of creating in a medium, I get to create the medium. I get to create a medium of taking pictures and sharing them. And it's not like I'm unique in that regard. It's what Facebook is about, connecting people with images. And a lot about what I'm going to talk about today with the technology is about this historical trend that started really, really long time ago. People have been doing this a very, very long time. And the thing that's interesting about this timeline as it passes through is we keep getting better at it. We're getting more sophisticated, sharing with more medium. But if you look at these, some of these medium changes are 1,500 years apart. But each time we're trying to get more information and share it more densely. And it's that process has accelerated to the point where we got into the 20th century and we started taking photos. The average person today probably sees around 300 to 500 pictures a day. That's on the order of 900,000 pictures a year, etc. You see a lot of images. It's how we communicate. And towards the end of the 20th century, we really made it easy for you to take moving versions of these things. And that changed the world some more because now you can compress and share more information. Last year, we took that a step further with Surround 360. Full stereo system that'll immerse you in imagery. This was the footage we shot at Grand Central Station. Wonderful footage. But after that experience, we went back and said, could we do even more? Could we take this to the next level? What would that look like if we did that? Put our heads together and said, well, we would like to capture not only 3D, but full depth. Earlier today, Shrep introduced the X24 and Facebook Surround 360, the next generation of system. This allows us to do a much more immersive capture. And I'll get into what that means because it has some profound implications, not only for the experience that you have, but how you use the imagery and how you share it. The first thing is it gives you full 6 degrees of freedom. It allows you to cut this data in a myriad of ways. As you go up higher in dimensions, you can also go lower in dimensions. And when you go lower in dimensions, like back to 2D, you can cut that data in a lot of different ways. And that's one of the power of shooting in 6 degrees of freedom. And I'll get into more what that really means as we go through the talk. This myriad of outputs is important because not everybody has a Rift VR in their house, and even if they did, they don't always run to it. So you want to be able to shoot and capture content and then share it in a lot of different ways. And not only share it in a lot of different ways, do a lot of different things, or make different cuts. In fact, if you think about it, historically cuts have been sort of a one-dimensional thing. You take a linear set of capture and you slice it in time. We're going to show you how to slice it in more than one dimension than time, including time. And that will give you a lot more creative flexibility. So not only does this camera give you more immersive capture, it gives you a lot more creative freedom in the cuts you can do. In order to get at those different cuts of data, you have to have tools to do that with. And by capturing depth in the way we do, we actually fit into existing CGI workflows. And I'll go into a lot of detail about that, because it's just not about this camera. It's about the entire ecosystem of content creation, capture, edit, and sharing. We also took a lot of feedback and said, make your cameras more portable, make them more small, make them be in a form factor that is usable by people who shoot images and video and cinematographers. It has to plug into that ecosystem, and portability is part of that. And we wanted to keep our image standards high, the quality of imagery high. We felt last year, and we feel this year, and we'll feel in the future, that the quality of imagery matters as much as the content itself, because the two interplay with one another. When we started this effort, we teamed up with FLIR Systems, who helped us integrate an entire camera system using our 6DoF architecture. And the neat thing about this architecture is, as you'll see, it scales in a lot of different interesting ways. The spherical architecture is important as well, and we'll get into that as we walk through some of the technology. But building real prototypes, shooting with them, and then learning from that and refining the software was critical last year, and it's critical this year. Not only did we look at the camera itself in terms of design and form factor, not only ease of use, ease of accessibility, each of those plates comes off, is easy to get at the cameras if you need to repair them. We wanted it to be rugged. We wanted it to be professional looking. We wanted it to be able to wick heat away so that it wouldn't overheat. All of these things are important in camera designs, especially multi-camera rigs. We also wanted to show that the architecture is scalable, that it's a 6 degree of freedom architecture. So we built a 24 and a 6, and we chose those to be sort of in bookends. But you could imagine more than 24. You can't really imagine much less than 6. That's effectively faces of a cube. But the idea was, would the software, would the system and all the pieces work with a different set of arrangements of cameras? And that was really important because that allows you to have scalability in price point, quality, all these attributes that you would normally have with a camera. You'd like to have them with this camera as well. And the other aspect is that it also helped us test our software, right? If you have a lot of different configurations, then you can say, does it really work? Where does the software break? And by having a lot of different configurations, going out and shooting with them, it proved our software and hardware architecture. Because like before, it's a computational camera. It requires compute in order to get the final images out. And each camera arrangement has a lot of different parameters trading off, as before: lens resolution, field of view, sensor resolution, and sensor positioning. All of that matters in any given instance of the 6 degree of freedom architecture. To do a little bit of a throwback to last year, just a mere 12 months ago, when we announced the Open Edition. That was a rousing success. It did exactly what we wanted to do. A year ago, we said we wanted to start this process, this journey off. We did it with an open source design. And one of the goals of the design was to encourage others, many in this room, to go off and build their own and grow the ecosystem. One of the questions I got was, aren't you worried that, is somebody actually going to build these things? And I said, not a concern. There will be people out there that build them. And out on the floor today and yesterday, I have 3 great examples: the ImageVision Zcam V1 Pro, the Onsemi 360 Endeavor, and the Kandao Obsidian. Give these guys a round of applause for going out and really pioneering and bringing this technology to market. I wouldn't have believed, even though I said that, hey, we were going to do this, I was hoping for one, and we got many, many more, and this is just a great example. Another good example is Reverge VR, who took our design, not only built one of these things, they went out and shot great footage. I want to show some of that right now. And it's just beautiful footage. It has music with it, but I turned it off so I wouldn't be competing with the artist. But just the sheer beauty of the imagery and the fact that people went out, used our software, used our hardware, experimented, and then gave us feedback. And that feedback was incorporated into the next series of designs. Things like make it more portable, make it integrate with workflows on the set, make sure your sound synchronized. All these things that are important if you're trying to use the camera. Things that you could ask somebody about, but if they try to use it, you really know about it, and you understand the limitations. So thank you, all of you that went out, and even the unknown people I don't know about who have gone out and pioneered. Keep the pioneer spirit up. If we were 1% done last year, we're maybe 2% done this year. But let me get into the difference between what we did last year technologically and what we did this year, and why we did it and how we did it. So Ring cameras, of which the Open Edition is, you get to have like 3-ish degrees of freedom. You certainly can move back and forth. You can move up and down, but you lose stereo as you go to the zenith and nadir. And you're really seeing 3D stereoscopically, not with any parallax. Means I can't move my head. I'm as if I'm fixed in this position. And that is limiting. That's really, really limiting. Also, that data, it turns out, that comes out of that system is hard to edit and work with because it's been flattened into 2-dimensional space. And so if there's any errors in the data, or you want to go in and add something in 3D because you see it in 3D or stereo, it's very, very hard. So we'd like to move into a direction that's more natural for humans, which is 6 degrees of freedom. This is where 6DoF comes from. And you do this every day naturally, right? And this is one of the reasons, one of many reasons, why you can close one eye and still see depth. Your head moves back and forth. You do that more often than you realize. It also creates a more natural viewing experience. And so that's the full 6 degrees of freedom. So what does that look like if I actually track this? So this is an actual live capture that we did. This is tracked from the head in the headset. And if you look closely, you'll actually see parallax as the person moves in and out and goes back and forth. And we have some demos of this. It is really compelling. And you can move your head a lot more than you might think, given the size of the rig. And the reason for that is that most of the scene, up to occlusions, doesn't change. So that back wall, if I move my head back and forth, I can move my head quite a distance, even if I took it at this position, because that back wall doesn't change. So you've got a lot more head motion parallax than you might expect. So how do we do this? I'm going to give you a real mouthful here. This is the most technical part. Spherical epipolar depth estimation. So let me tear that apart. You can impress your friends by memorizing that and sharing it at parties. Probably not, but anyway. So for well over 50 years, if not longer, people have been using classic photogrammetric techniques to estimate depth. Every topological map that you see is done this way. They take an airplane, they fly it over, they take a bunch of pictures. Then, since they knew where the cameras were, and they know the distance between the snapshots, they triangulate down and find the triangulated point. This is simple high school geometry. It gets more complicated than that, but at least at the very high level, that's what you do to get a piece of depth information. We have a spherical capture that's instantaneous. Instead of moving the camera around linearly in an airplane, we arrange the cameras in a sphere and capture a whole bunch at once. Now that's one of the reasons we arranged the cameras in a sphere, was precisely so that we would have even sampling in space, so that any one point in space would be seen by enough cameras so that we could do this triangulation. So this triangulation, pairwise triangulation, is known as epipolar geometry or epipolar sampling. It's a fancy word for noticing that if you have two planes, image planes, that if you move along depth in one of the images, it moves along a line in the other. And if you do it in a spherical coordinate system, there are spherical curves. So all of this means the same thing as you would normally know about if you had taken a course in photogrammetry. Now it's a little trickier than that, as we'll see here. So we take and look at a single point in space, and if that point moves around, you can see the different cameras see that point, and the closer you are to the camera, the more it moves in each of the cameras. And this is where the tricky part comes in. You don't know the depth, and that is what you're trying to find. But unfortunately, where that point on the image is a function of depth. So somehow you have to find the matching point. This is the fancy term for this is the stereo correspondence problem. This is a problem that's been probably studied for 20 to 30 years. It is getting better all the time. And some of the best techniques use some of the math that Joaquin and Schrepp alluded to in their keynotes with machine learning. You can understand, the more you understand about the scene, the more likely it is you can say that this point in this image matches that point in another image. You grind on that, and now you have two correspondence points, and now because you've carefully measured where the cameras are, you can now triangulate and compute the depth. The nice thing about this, if you calibrate your cameras very carefully, which we do, is you get what I call metrological information. You know exactly how far away that point is, and points that are adjacent, you know how far they are away from each other. That means objects that get rendered at the right scale, and you have the data at the right scale in all parts of the scene. We'll see how this becomes important in the workflow. So we do this in 3D. And do it with a lot of overlapping cameras. We overlap the cameras a lot in order to make sure that at least 2 cameras see every point some high percentage of the time up to occlusions. And I'll talk a little bit about that. So this is what it looks like, and one of the benefits of having a fully spherical rig is you can turn it upside down, you can rig it any way you want. This is it's sitting on a techno crane. For those of you who've been in Hollywood and in the movies, this is a gizmo that allows you to move cameras around in a scene. We just attached it, turned it upside down. The white stuff on there is actually LEDs that we use to illuminate the scene from the vantage point of the camera. So what does this look like? So we're going to show you a little clip here. And so what you saw was the depth map. I'll talk about that more. But you see that wiggling. That is actually your head moving around. And this was a real live captured scene we captured in Cal Academy. And you can see that if you move your head around, you actually see the imagery as if you were moving your head in this. This is a fancy term for this is a wiggle stereo. But you can kind of see the 3D nature of the scene. But let's dig into this a little bit more. Here's another piece from that same underwater piece, and you can actually see that even the fish are in 3D. And again, you have this full head motion parallax. This has not been captured before in a video. So you're seeing time evolution of head motion parallax. This is really amazing. Now let's tear this apart a little bit. This is that scene before we shot it with the clapboard. And let's look into the scene. So this is the depth map. Black means closer to 0. White means farther away. And you can see we've accurately captured the depth map. We'll do it again for an on-set scene. And we can now again see that depth. And that is correct, meaning if you translate those pixels into centimeters and meters, you get the right distance. Similarly for a different scene, and once you reach out to the hyperfocal distance, at some point you can't resolve depth anymore. You just don't have enough fused information. You'd either have to separate the cameras out farther or have higher resolution cameras. So how does this sort of work, and what does it produce? The important thing is it produces RGB and depth images. So the camera sees a lot of information as if they were rays coming out of the camera. You build up this point cloud with the point correspondence, and if this is what comes out of the camera, at least in an animation. And you can see there's occlusions, shadows, where the camera can't see. It can't see through objects. So if you move your head enough, eventually it just disappears, right? You haven't captured that data. But it captures a lot of the data, and enough of it so that you have a rich image. The other interesting thing is because it's depth data, you can do a lot with it, and we're going to walk through this. So this is kind of a cool thing. We can create this kind of electric effect. What's fun about this video is one of our engineers in Oculus says, "Oh, you have this data, let me play with it." And this is what he did with it. All he's doing is sweeping through and creating an electrical image as a function of depth. But we're going to see a lot more cool stuff here in a little bit. So here is that depth image of one of our engineers, Albert. He's in all of our images. He's famous. And we can subtract that image out. We can also blur the background and foreground. We can replace the background with various scenes. And this is all with just one image. So what you just saw there was effectively green screening an outdoor image with no green screen. Now think about that in terms of workflow. Think about it in terms of creative avenues. And again, when you think about these cuts, these lower dimensional cuts of the higher dimensional data, this is an example of cutting that data a different way. You know, you may be sitting there and say, well, Hollywood does this all the time. What's the big deal? Well, they do it all the time, but they do it with a fleet of people and tools, painfully sometimes, as one of my colleagues is smirking about. And sometimes it's just impossible. The data wasn't captured. So this is a really important element. So let's talk about what that means for post-production workflow. The other thing that we're announcing today is a full ecosystem workflow, from camera all the way back out to distribution. This workflow is exceedingly important, and the fact that we have depth data makes it possible. So you start with capture, you build up depth estimation, and you feed it to a series of editing and post-processing tools to create your vision. There's a lot of different pieces in this. There's the cameras themselves, which we announced today. And then there is a series of tool chain folks that we have partnered with in order to make this possible. The first is Otoy. They are well known for working in this space of volumetric data. Their tools are amazing. They've been doing it for a long time. Adobe, the Foundry, Metal, and Otoy again, and all of these pieces come together in a whole workflow, starting with the raw data, producing the depth and video in 360, and then re-outputting that in variety of formats, including formats that can go into newsfeed, can go into headsets, it can be stereo, it can be 6 degrees of freedom, it can be 2D cuts. This is huge, this workflow, because it's the way you take this data and do cool stuff with it, and allows both an increase in productivity and also an increase in creative opportunities. I'm going to go into a lot of these tools and take a deeper look at what these tools can do and what you can do with this data. Now, I want to thank all of our partners, because it was an amazing group effort, and also it's super exciting to create tools and formats that are totally revolutionary, and that's what we've done here. So let's see what we can do with this. First is the Foundry tool of Kara VR. Many of you have probably used this tool. You can directly take the data out of our camera and put it into this tool. These are the lines you see are the overlaps. The numbers are the camera numbers. And they can go ahead and use traditional stitching software. So here is Adobe and Metal working together. And in fact, oops, yeah, did I go back? That's fine. Can you move it back one? Thank you. I have the button. One more. Oops, sorry. There we go. The interesting thing in this image is there's multiple layers in depth. Here we fused an artificial element, we blurred the image, and now we have a fused new digital product. In this case, working with the Point Cloud Foundry and Foundry tool Nuke, we can directly put another 3D object in. It's rendered as a coarse point sample, and now again, because that's metrological, that object has the exact size of maybe a cube this big sitting on that stump. And while it's artificial, you can get the sense of what it would mean if you were to bring it into that part of the tool chain. So what we're showing is integration into well-known workflows, so as to allow you to create, but create in a space that you're familiar with. Here is Otoy's plugin in Foundry. Here the camera is virtually being moved around, another 2D cut. that I talked about. But what's cool is you can add all sorts of interesting 3D effects. And when you do that, they actually behave in the way you'd expect because the world's now 3D. You've captured real 3D data, and now you can do cool things with it. In this case, we added this artificial fountain. It does the right refractive and reflective things with the light, and it will get the right answer because when it refracts the rays and everything else, the thing behind it is really a 3D object. So capturing real depth data has some profound artistic implications in addition to increased immersivity. Here's a cool demo. You can also add artificial objects, and the artificial objects do the right thing. They light the scene up. And because you have real geometry, you have real normals. Because you have real normals, you can take the light away, subtract the light out, and put new light in, and that's called relighting. So that's yet another dimension of cutting this data. So now you can start to see the power of a camera like this and an ecosystem like this. It's just not about the data, it's about capturing the right data and moving it through the entire ecosystem. It's truly amazing. So this is a shot from one of the pieces we recently did, and I call it the impossible shot. At first blush, you're going to say there's nothing special about that. First of all, these guys started from this far apart on the stage, and they're crisscrossing. And they're slowly crisscrossing, and I've crisscrossed the cameras, and they're going to crisscross back out again. I claim that this is a very difficult, if not impossible, shot to do with regular cameras. That's because the cameramen would have to crisscross one another, or you'd have to shoot multiple times and keyframe them and do all sorts of gymnastics. It's a very, very rudimentary but exemplary way of showing the virtual nature of this camera. We basically have one camera that turns itself into many virtual cameras. And because we can move the viewpoint and slice it different ways, we can do all sorts of amazing things for normal 2D output as well as a fully rich, immersive experience. I can hardly wait until all of you can start to shoot with this system, work with this system and ecosystem that we've created, which is truly epic because it's in your hands that great things are going to happen. We're committed to VR. You saw it today, and the whole experience of sharing imagery. It's central to who we are. Our project is committed to the cinematic communities and all of you creators out there, big and small. We promised last year to continue to invest, and we have continued to invest, and we will continue to invest, because we believe that this creativity will trickle down and be shared with the world, not only by great content creators, but small ones as well. This year, we will be shipping the entire tool chain, all the pieces, all the data interconnected. We've added other partners, such as DxO, who are committed to making and measuring great quality. Many of you probably know their products around quality. We have a number of post-production houses that are helping use these tools, integrate these tools, and use the data. This is super important because, again, this is the end-to-end creative chain. And it's not enough just to capture the data. We should really give our partners a big round of applause for taking on this great project with us. It's exciting. We're 2% done, and we'll keep at it. Thank you very, very much for coming to F8.